Buff Lopez, I'm an analyst in our materials and chemical sector. Among other things, I've researched a few topics across the battery landscape, the mining industry, and right now I'm diving into bioplastics, so excited about that. Essentially, if we break down a battery, it consists of a negative terminal, which is the anode, and a positive terminal, the cathode, maybe in some kind of electrolyte. And there's a few other components in there. But the negative terminal side of things, there's interest in innovating the materials that are being used, because currently graphite is the preferred material for the anode. Unfortunately, graphite itself is predicted to be in shortage in the coming years and is already classified as a critical raw material by the US DOE. Graphite itself is really great. We use it in batteries. If it wasn't in shortage, we probably would not be interested in finding other materials to put into the batteries. But like I said, unfortunately, it's in shortage. So silicon, the potential of silicon to be used as a conductor in batteries has been known for quite some time. But previously, there were some challenges with silicon, namely its fickleness with expanding. So reports have cited over 400 times expansion of silicon in batteries. And if you think of that on a larger scale in an EV, you would just need a huge battery pack in a huge EV that would just be uneconomical at scale. So they kind of put that to the side. In recent years, however, there have been some innovations that contain silicon's expansion while also allowing it to be a good conductor to be used in batteries. So there's a really great innovator that we spoke with for this research called Cleantech Group. And so essentially what they're doing is containing the silicon to be used in manufacturing anodes. And this is important because manufacturers themselves, not all of them have developed in-house solutions to be able to contain that silicon. And also not all of them have been able to do that at a cost that is competitive with other manufacturing processes. Then we get to the silicon anode developers themselves, whether they're developing or containing the silicon in-house or they're outsourcing to someone like Cleantech Group, then they're actually manufacturing the anodes. And this can be done in a number of different ways. They can do this by adding additional coatings to contain the silicon or maybe increase the conducting performance. They also may be interested in using 100% silicon, or maybe they're interested in using a sort of blend like silicon graphite. Funding for silicon anodes in 2023 unfortunately dropped off to about 133 million raised, which was a pretty steep drop off from 2022 when we saw over $596 million raised for silicon-based materials. Despite that, it still has attracted more funding compared to other clean tech anode chemistries. And that funding has been attracted from major automotives like GM, Porsche, Tesla. I think we'll look back on 2022 as a historic high for silicon anodes, but overall the trend for silicon anodes has increased. So I think that we'll, in 2024, hopefully see continued funding in this space because there are other exciting innovations emerging. There's a great innovator like Silib who uses a one-step manufacturing process to manufacture their silicon anodes. That'd be a relatively simple process without needing commercial manufacturing equipment. There's other innovations like from Solid Power who are trying to develop solid state, 100% solid state silicon batteries, but that's definitely more forward looking and probably not going to be widely adopted anytime soon.